Okay, guys, so we're continuing on with our history of the atom today, but we're almost done, don't worry, and then we get to talk about what an atom actually is and what makes up an atom. So we left off last time talking about J.J. Thomson, and he was using this tube, if you remember, and he discovered the electrons because the beam of gas was bending one way or the other, and he had that plum pudding model. So now, after Thomson's experiment, he says that, okay, so I have an atom, and I think all this substance here is positively charged, and then there's little negatively charged particles within this positively charged solid mass. That's the rest of the object. So we have these little negatively charged particles, and he says the rest of it is this solid mass, and it's all positively charged. And like I said last time, we know that that's not correct, but that's what they thought at the time. And so around 1900, they're still thinking about all this stuff. And then we had Rutherford comes by, the scientist called Rutherford, and he does this experiment basically, and he determines that he basically determines that there's a positive charge in the atom that's densely concentrated somewhere, and it's not all spread out like this. He says that, hey, there's this kind of one point, or this small area where all of the positive charge is. And so we know now that that center would be the nucleus, called the nucleus. So now Rutherford has found the nucleus, and so now he says that, okay, so now he says that there's this positively charged nucleus, and then he says there's these electrons must be outside the nucleus, and they're kind of doing their thing around the outside of a nucleus. So that's what Rutherford's model now. And he also coined the name. He called these positively charged particles in the nucleus protons. So now we have scientists think electrons are around the nucleus and protons are in the nucleus. We're getting closer, almost there to our full atom. The last person, James Chadwick, did some experiments, and basically he's the one who discovered neutrons. He discovered neutrons, and they're also in the nucleus, and they're neutral charge, so they do not have a positive or a negative charge. They are electrically neutral. And so now we've arrived at kind of the modern day understanding, this simple modern day understanding of what makes up an atom. We have neutrons, protons, and electrons. And over here you can see, here's a model of an atom. This is a lithium atom specifically. The orange balls here are the protons, green are the neutrons, and then the purple ones around the outside of the nucleus are the electrons. So this would be like the nucleus right here. The neutrons and the protons would be inside the nucleus. Now, one other thing that's of important note is the mass, the relative mass of each particle at least. Protons and neutrons have about the same mass, but they're a lot more massive than the electrons. Electrons are tiny, tiny compared to a proton or a neutron. So if we write that, we know protons spelled that wrong, equal neutrons in mass, and they're a lot bigger than electrons. And you'll see this abbreviation a lot for electrons. E negative means electrons. So protons equal neutrons in mass, and they're a lot bigger than electrons. Electrons are tiny compared to the protons and the neutrons. The last thing in this lesson talks about the number and ratio of subatomic particles within an atom and how they determine the properties of that atom. Basically, that's saying the number of protons and neutrons and electrons that an atom has determines its properties. So this is lithium, and we know that because lithium 3, the atomic number, this right here is the atomic number, is how many protons that an atom has. So protons, the orange, we have 1, 2, 3. And then if it's electrically neutral, if it's a neutral atom, then there'd have to be the same number of electrons, right? 1, 2, 3, because protons are positively charged. So if we have 3 positively charged protons, we need 3 negatively charged electrons to balance it out if it's neutral. Now obviously we talked about ions. Ions are different, and we'll talk more about ions at a later date, but just know if it's electrically neutral, it has to have the same number of protons and electrons. And actually this number down here is the atomic weight, and that'll be a different lesson, and actually there should be another neutron down here for this to be accurate, but don't worry about that too much now. Those will be lessons down the road. And just one last thing to emphasize here. The atomic number we talked about, 3, is the number of, that's always the number of protons. And to be that element, that's always the same. If it's lithium, it will always have 3 protons. If we have carbon, carbon's atomic number, if we were doing carbon in this square, carbon has an atomic number of 6, then carbon will always have 6 protons. If it had a different number of protons, then it would not be carbon, it would be a different element.